Hi, hi students. Today we are going to discuss about the indirect load testing on transformer. Indirect load testing on transformer. What is meant by testing? Testing is done to determine the performance of the machine. Determine the performance of the machine. We know that we have two types of testings are there. What are those two types of testings? One is indirect method of testing. One is indirect method of testing. One is indirect method of testing, and next one is the direct method of testing. Indirect method of testing and direct method of testing. And you know that what is mean by direct method of testing? By applying the load actually, we are determining the efficiency. That method we call as direct method of testing. Indirect method of testing is nothing but without applying the load actually, we are determining the efficiency. Determine the efficiency. That is we call as indirect method of testing. See that here? The efficiency and the regulation of transformer on any load condition at any power factor condition we are determined. That method we call as indirect method of loading. Indirect loading of the transformer. So in this method, the actual load is not used on transformer. In this method, the actual load is not used on transformer, but the equivalent parameters of transformers are determined. But the equivalent parameters of the transformers are determined by conducting the two tests. What are those two tests? One is the open circuit test and one is the short circuit test. One is the open circuit test and one is the short circuit test. And see that coming to a point of the key point here, the parameters which we are calculated by these two tests, those are effective. Those are effective in determining the regulation and efficiency of a transformer. The parameters which we are going to find from this open circuit test and short circuit test, those are very helpful to find out the regulation and efficiency of the transformer at various load conditions, at various power factor conditions, without actually loading. Without actually loading. That is. And next one, what is the one more advantage? The advantage of this indirect method of testing is nothing but the power loss is very less. The power loss is very less. And next one, with very less amount of power, the results can be obtained. Now, we are detailedly study about the open circuit test and short circuit test of the transformer. Open circuit test and short circuit test of the transformer. See that, dear students, this is the circuit diagram of the open circuit test. This is the schematic circuit diagram of the open circuit experimental setup for the open circuit test. Experimental setup for the open circuit test. See that here, this is the experimental setup for the open circuit test. Open circuit test. See that. So what are the elements are used here to design the open circuit test? First, we consider the transformer. We consider the transformer. The transformer having the two windings. What are those two windings? One is primary winding and one is secondary winding. Primary winding and secondary winding. See that here. So this primary winding, the primary winding is the LV winding. Primary winding is the LV winding and secondary winding is the HV winding. Secondary winding is the HV winding. So why these tests we call as open circuit test? The secondary winding is kept in which condition? Open condition. The secondary winding is kept in open condition. When secondary winding is kept in open condition, so E2 is equal to V2. E2 is equal to V2. And next one, so what are the measuring parameters? The measuring parameters are ammeter, wattmeter, and voltmeter. Where we are connected, these all measuring parameters. These all measuring parameters are connected the which winding? LV side. Which winding? LV side. How we are given the supply to the entire circuit connection is nothing but with the help of variac. The help of variac. So variac is nothing but single phase auto transformer. Variac is nothing but single phase auto transformer. See that here we are studying about the open circuit test. By doing these tests, we are determining some equivalent circuit parameters and also the losses. What are those equivalent circuit parameters are we are determining or not? And next one is the X naught, and next one is the IC, and next one is the IM. So these are we are determined by open circuit test. And along with that, one more important one is the iron losses. Iron losses. So here iron losses are measured under which condition? No load condition. Now the transformer is operating under which condition? No load condition. In open circuit test, we measure the which losses? Iron losses. We measure the which losses? Iron losses. Now, detailedly, we are going to the topic step by step. Is that here? So this is the transformer primary. So the transformer having the two windings, the primary winding and secondary winding. The transformer primary is connected to supply through the ammeter, wattmeter, and variac. Okay. The secondary of the transformer is kept in which condition? Open condition. The secondary of the transformer is kept in which condition? Open condition. And next one. So which winding is used as a primary winding? Low voltage side is used as a primary winding. High voltage side is used as a secondary to conduct which test? Open circuit test. While conducting the open circuit test, primary winding is the low voltage winding, secondary winding is the high voltage winding. And next one, this primary winding is excited by the rated voltage. The primary winding is excited by the rated voltage. So that rated voltage can be applied with the help of the variac. That rated voltage can be applied with the help of variac. And next one, so what is the use of wattmeter? The wattmeter measures the which power? Input power. The wattmeter measures the which power? Input power. That input power is iron losses. That input power is the iron losses. Wattmeter is always measures the power. Okay. The ammeter measures the input current. The ammeter measures the input current. The voltmeter gives the rated primary voltage applied at rated frequency. Here, three measuring parameters are there: ammeter, wattmeter, ammeter, and voltmeter. Wattmeter measures the input power, ammeter measures the input current, voltmeter measures the rated supply voltage. Rated supply voltage. Due to operating the transformer under no load condition, the output voltage V2 is equal to V2. The output voltage V2 is equal to V2. And next one, so when the transformer secondary winding is open condition, so you know that the value of resistance varies from 0 to infinity. The value of resistance varies from 0 to infinity. So when the resistance is 0, the resistance is 0 under short circuit condition, the resistance is infinity under open circuit condition. So that's why here the secondary winding resistance is very high. The secondary winding resistance is very high. Why? Because secondary winding is kept in which condition? Open condition. Okay. And next one, open current. So here the value of current is negligibly small. The value of current is negligibly small. So with the help of voltmeter, we measure the rated voltage. With the help of ammeter, we measure the input current. With the help of wattmeter, we measure the input power. And next one, come to the point. So there is a tabular column. So this is the tabular column for open circuit test. Tabular column for open circuit test. So what are the three parameters are there here? Voltage, three quantities, V naught, I naught, W naught. What is V naught? Rated voltage which we are given. That is the, for example, single phase AC supply 220 volts is nothing but rated voltage is equal to 220 volts. And next come to the point of I naught that can be measured with the help of in ammeter. W naught that can be measured with the help of the wattmeter. See that here. What is V naught? V naught is equal to rated voltage. What is W naught? Input power. What is I naught? Input current. It is also called as a no load current. It is also called as a no load current. When the transformer is operating under load condition, here I1 is equal to I naught plus I2 dash, I naught plus I2 dash. The transformer is operating under load condition. I naught, I1 is equal to I naught plus I2 dash. When the transformer is operating under no load condition, the value of current I2 dash is equal to 0. When I2 dash is equal to 0 under open condition, I1 is equal to I naught. I1 is equal to I naught. You know that. So I naught having the two components of current. So I naught is the vector sum of two components of current. What are those two component currents of the I naught? I naught is equal to Im plus Ic. I naught is equal to Im plus Ic. What is Im? Magnetizing component current. What is It? Ic, core loss component current. What is the formula of Im? I naught sin pi naught. What is the formula of Ic? I naught cos pi naught. And next one, this cos pi naught we call as the no load power factor. Cos pi naught we call as a no load power factor. What is the expression of wattmeter reading? The wattmeter expression W naught is equal to V naught I naught cos pi naught. W naught is equal to V naught I naught cos pi naught. See that here we know the value of W naught from the tabular column and we know the value of I naught from the tabular column. V naught and I naught from the tabular column. Which is the unknown value here? The unknown value is the cos pi naught. The unknown value is the cos pi naught. Now we are finding the cos pi naught. We are finding the cos pi naught. See that here? How we find out? See that? Okay, sorry. See that here? This is the vector. Just now we discussed no load current having the two components of current. What is I naught is equal to Ic plus Im. Under no load condition, I1 is equal to I naught. Why? Because I2 dash is also 0. I2 is equal to 0. When I2 is equal to 0, the secondary copper losses are 0. Now I1 is equal to I naught is very low value. What is the percentage of this I1 current at the open load condition is nothing but our open circuit condition 2 to 4% of the full load current. So under no load condition or open circuit condition of transformer, I1 is equal to I naught. This I naught is the 2 to 4% of the full load current. 2 to 4% of the full load current. Due to operating the no load condition, I2 is equal to 0, the copper losses are 0. And there is a mostly which losses are occur here? Iron losses. Why? Because iron losses are depends on the voltage. Iron loss are depends on the voltage. But the total copper losses in the open circuit test are negligibly small. Negligibly small. Okay. So due to that, which losses we measure, the total input power is used to supply which losses? Iron losses. That's why W naught is equal to input power. W naught is equal to input power. Now we are going to finding the parameters of the transformer under which condition? No load condition. Which condition? No load condition. See that here. What is the expression of no load input power? W naught. W naught is equal to PA. PA is nothing but the iron losses. That is W naught is equal to V naught I naught cos pi naught. We know the value of W naught, V naught, I naught from the tabular column, which is the unknown value cos pi naught. Cos pi naught is equal to W naught by V naught I naught. This is the no load power factor. No load power factor. After finding the cos pi naught, find out the core loss component of current, core magnetizing component of current. What is the expression of core loss component of current? Ic is equal to I naught cos pi naught. What is the expression of magnetizing component current? Im is equal to I naught sin pi naught. You know that the transformer is operating under no load condition, so the equivalent circuit consisting of only two branches. What are those two branches? R naught and next one is the X naught. R naught and X naught. These two are connected in parallel across the supply. These two are connected in parallel across the supply. So what are those two? R naught and X naught. R naught is the no load resistance and X naught is the no load reactor. So it supplies the current I1. So this V1 supplies the current I1. So under no load condition, I1 is equal to I naught now. I1 is equal to I naught. Again, it is divided into two components of current. One is IC and one is IM. IC is flowing through the R naught. IM is flowing through the X naught. IM is flowing through the X naught. So these two are connected in parallel. Again, this entire branch is across the V1. So the voltage across the R naught is equal to voltage across the X naught. That is V naught. V1 is equal to V naught. No load voltage. V1 is equal to V naught. So R naught is equal to V naught by XC. X naught is equal to V naught by IM. X naught is equal to V naught by IM. So this is the procedure to find out the no load parameters of the transformer by doing open circuit test. by doing the open circuit test. Okay. So here, so with that, we completed the topic of open circuit test on transformer. By doing the open circuit test, we are finding the no load parameters of the transformer. What are the no load parameters of the transformer? R naught, X naught, IC, IM. And one more additionally, we are measuring the iron losses of the transformer. So that iron losses are measured with the help of the wattmeter. The help of the wattmeter. So dear students, this topic is very important for exam point of view and competitive exam point of view. Okay, JN2 point of view and competitive exam point of view. So be careful. You have to practice the expressions with the help of pen and rough paper. So then only you will get and you get an idea. So otherwise you never get the idea. So first listen the class carefully. Next you have to practice. Okay. Okay, the next topic we are going to discuss about the short circuit test on transformer in another video. Okay, thank you, ma. Thank you, students.